were OSU Extension has a long history of trying to help farmers better utilize their liquid manure, whether from a swine operation or a dairy operation. While our humble beginnings of helping farmers with this were to help farmers look at how to better utilize their manure on wheat crops, it quickly moved for how to utilize manure in growing corn. From there, we started seeing manure tankers with narrow tires put on them to allow us to go down between corn rows. That research helped us to learn that we could easily utilize swine manure to achieve very similar yields to side dressing corn with either anhydrous ammonia or 28%. The problem with manure tankers, though, is they cause a lot of compaction and are very inefficient. It takes a long time to move all that manure to and from the field with a manure tanker, and many of our larger operations are now using drag lines. In order to keep up, we then began doing research to see if we could run over growing corn with a drag hose, whether 5 inches or 6 inches. From that research, we found out that we could actually flatten corn up to the V4 or V5 growth stage without hurting yield. From there, Glenn Arnold, OSU Extension, State Field Specialist in Manure Management, worked to purchase 3 toolbars that will side dress 12 rows of corn, and those toolbars are now utilized around Ohio for farmers to try out firsthand side dressing corn with liquid manure. An identified challenge of utilizing a drag hose in growing corn is that often drag hoses are utilized going at a 45-degree angle across the field. OSU is now working with farmers to try to determine how to drag line corn straight so that fields do not have to be planted on a 45-degree angle. An additional identified challenge is the variability that liquid swine manure has coming out of the barn. Today I have with us Chris Schaup, who is a graduate research associate working under Dr. John Fulton on precision manure nutrient placement here at Ohio State. Chris, will you share with us a little bit about what you've learned over the summer about the variability of manure coming out of swine facilities?
Thank you, Jason, for having me on. I'm excited to share some of my preliminary results from my research. For some perspective, I would like to share how my research has been set up first. I'm trying to characterize the changes in a pit over time so that we can determine consistent and inconsistent trends from one pit to the next. As many of us know that are working with livestock, manure in a pit or lagoon stratifies and settles, and agitation can be risky due to the gases that are released from the manure during this agitation process that can be very harmful for the animals or humans that are above the manure when this agitation occurs. Pit management, additive use, along with nutritional diet of hogs or cattle, if you're working with on a slatted feeding floor for fat calves or dairy cattle, these nutrients can vary widely from barn to barn and even just from different times of the year. Through partnership with Glenn Arnold and Sam Custer, we have had the opportunity to install some sampling ports on their manure side dress toolbars and pull samples every 20 minutes throughout the application process, right from the applicator as it's being injected. We averaged about 9 samples per pit, and the average amount of manure that we were pumping was about 220,000 gallons per pit. There was some variation. I think the lowest we had was about 7 samples, and then the most we had was 13. And we can get right into my research now, look at some data analysis. We're going to focus on 2 nutrients today. We're going to look at total nitrogen and phosphorus, purely because those nutrients are most widely concerned as far as how to manage them better with water quality issues that are rising here in Ohio and elsewhere as well. Let us start with the total nitrogen table. A couple of things in this graph that I would like to call to your attention to is when the pits were agitated and the hogs that were in each barn. As you can see, some were agitated, and I kind of put when they were. We have 8 days, 7 days, morning of, and during. And then you can keep in mind that the 3 of the barns are finish hogs, so fat hogs going from 60 pounds to finish weight at 280. And then you're looking at a nursery building, which had hogs from 12 pounds, trying to get them up to that, hopefully 40, 45 pounds. So the nutrient content is going to be a little bit different. So the impact that a week of settling can have on your manure application is very apparent, as well as that nutrient load in that nursery barn compared to the finishers. But the trends is very interesting between the gray line and that yellow line. They are pretty similar, with both being agitated close to pumping. Another thing that we're seeing here in these graphs is the variation that pits that were agitated a week before. That time was enough for many of the nutrients to settle out and stratify. And then the two applications side by side do not yield any similar trends. And the blue application starts around 150 pounds of nitrogen per 5,000 gallons and ended at 215,000 with those spikes and dips throughout. Whereas the orange line, you see the dip in the middle, but a trend would be more or less flat there across 200 pounds per 5,000 gallons. Next, let's move on to the phosphorus graph. Keep in mind the differences in the hog type in the barn with the finishers and the nursery pigs, and the size and the feed ration that they'd be fed, as well as when they were agitated prior to or during application. As you can see, agitation does help a lot with the consistency and mitigates the drastic changes. But for the finishing barns, 10 or 12 extra pounds of phosphorus could become a problem, let alone the pits that were agitated a week prior. The gray line really does trend down, which is opposite of the orange and blue line. But that change from 120 pounds down to 95 or 100 is quite a difference between the two, between start to finish. But then as you're looking at your blue and orange lines, that increase over time, almost doubling in phosphorus load, is a huge challenge for the industry as far as manure management goes, and is something that we're trying to mitigate through this process of trying to figure out these consistencies and trends. Now let's move on and look at the two graphs side by side. There are some similarities between the two graphs, but how would a farmer be able to plan ahead for the changes depicted between nitrogen and phosphorus? Neither nitrogen or phosphorus proportionally move in the same degree as the other graphs. They're kind of independent of each other, which would be a huge challenge for a farmer to prescribe an application. And that is how I'm going to segue into the second portion here. For the end of the video, we're going to talk about what's the upcoming technology for manure application. Agriculture is changing, and automation is being incorporated into most jobs on the farm. From robots milking, mixing feed, and pushing silage, to auto steer, row shutoffs, delta force, and so on, agriculture has evolved into precision ag and even more into digital ag. Sensors are allowing us to record and adapt and do our jobs better and more cost effectively. Through the use of near-infrared spectroscopy, or NIR sensing, companies such as John Deere and Topcon, among others, are developing a way to record manure applications on the go with the ability to manage the application rate of the manure depending on the nutrient need of the field. The development of these sensors started in Europe to meet the record-keeping needs for their environmental standards, and are making their way to us as nutrient management is becoming more and more important. These sensors are still being developed and calibrated to our production systems, but are just the start of cool and innovative ways to meet the needs of our crops and minimize nutrients that get away and run off our fields. I really appreciate being a part of this video. I hope everyone's having a good FSR.